This is video 3.1, day 4, word problem group work. You should have a worksheet to go along with this. Feel free to pause, stop, or replay if you need. These are word problems. The way I set them up may be a little different than how you thought to set them up. I can think of at least 2 ways to set up question number 1. If you want to try it the opposite way, or using, for instance, the sum of 2 numbers is 34 as the let statements, you could do that and then use the first number is 5 less than twice the second as the equation. However, I'm going to use this as this is the let statements, this is the equation. Please feel free to ask me if you see a different way to solve this. Please share that. More ways we can, use to solve problems, excellent. I would really like to hear that tomorrow in class. So, the sum of 2 numbers is 34. The first number is 5 less than twice the second. What are these numbers? I'm going to use that as my let statements. The first number is 5 less than twice the second. I know something about the first number, but not the second. That's my x. So let x equal second number, and I'm going to use the hashtag symbol. The first number is 5 less than twice the second. 5 less than means minus 5. So the 2x comes first. Twice minus 5. That's the first number. The equation says the sum of these numbers is 34. There's my equal sign. Sum means add them together. So the second number plus the first number equals 34. I'm going to leave all the equation solving today for you to do. I'm going to set up the word problems. So now you can pause the video, finish solving this equation, answer both let statements, and sable, sentence answer box label, your word problem. We'll go over it tomorrow in class. Number 2, if 6 times a number is decreased by 6, the result is the same when 3 times a number is decreased by 12. And I believe this should be the number, because it's not talking about another number. Find the number. Yes, it's only talking about one number. Find the number. Well, that's easy. Let x equal the number. If 6 times a number is decreased by 6, the result is, that's the equal sign. So 6 times a number is decreased by 6. That's on the left side of the equation. Then comes the equal sign. And the words that come after the equal symbol in English is the expression that goes on the right side of the equation. Is the same as when 3 times the number is decreased by 12. So 3 times that number, which I'm calling x, is decreased by 12. Well, that means subtract. 3 times the number, decreased by 12. Find the number. Variables on both sides. Solve it carefully. Sable. Number 3. At a Frontier field, each box seat costs $2 more than each reserved seat. Each bleacher seat costs $2 less than a reserved seat. I'm not sure this is all true, but that's okay. If the price of 2 box seats and 3 bleacher seats is $38, find the cost of each seat. Well, we have box seats, reserved seats, and bleacher seats. Box seats being compared to reserved, bleacher seats being compared to reserved. Reserved seats, I know least about, they are the x. And I could say S for seat. I don't have to use x. Let x equal the reserved seat. At Frontier Field, each box seat is $2 more. Well, that means $2 plus x. I'm not going to put the decimals in. I'm going to say 2 plus x. I could say x plus 2. I could turn that around. Say, it's commutative. Adding is commutative, so that's okay. So let 2 plus x, $2 more, for the box seat. Each bleacher seat costs $2 less. So x minus 2, $2 less than the reserved seat, means x minus 2. That order does matter. It's not commutative. Subtraction is not commutative. So that is the x minus 2. That's the bleacher seat. Okay, now reading the next sentence is going to tell me my equation. If the price of 2 box seats, so I'm going to take my 2 plus x and multiply both parts by 2. So this is a distributing problem. Because that's a quantity, 2 plus x. It's not just a single number. It's two terms. It's a quantity. It's a binomial. Must do the 2 times as a distributive problem. If the price of 2 box seats and 3 bleacher seats, again, we have a quantity, 3 bleacher seats, is $38. And again, I'm not going to put the decimals on there. That's the equal sign. Find the cost of each seat. So we have double distributive, like terms, watch the negative, solve, and sable. Number 4, in a baseball game, the Red Sox had 3 more hits than the Yankees. I'm not sure that always happens, but possibly in this game. I'm a Yankees fan. If 4 times the number of hits the Yankees had was equal to twice the number of Red Sox hits, how many hits for each team? In a baseball game. The Red Sox had 3 more hits than the Yankees. That statement is the let's statements. This is the let's statements up here. The Red Sox had 3 more hits than the Yankees. They're the X. And yes, I usually write all over my word problem. So let X equal the Yankees. I have to do that. It helps me figure it out. It helps me break down the word problem. If 4 times the number of hits the Yankees had, so I know it's going to be 4x, was equal to, that's the equal sign. So 4x, oh, I didn't make my let's statement for my Red Sox yet. Red Sox had 3 more hits than the Yankees. So let x plus 3 or 3 plus x equal the Red Sox. Forgot that. Now go on to the equation. If 4 times the number of hits the Yankees had was equal to, that's the equal sign, twice the number of Red Sox hits. Again, it's a quantity, must distribute the 2 or the twice to both the x and the 3. How many hits for each team? That's the equation. So you're going to distribute or not. You could divide by 2 on both sides first. Be interesting to see how many of you do that. Or distribute first, your choice. Solve the equation and sable. Number 5, Mrs. Gribben travels 12 less miles each day than Mrs. Katina. That is true. The difference between the distance Mrs. Katina travels in 6 days and the distance Mrs. Gribben travels in 5 days is 75 miles. Lots of words there. How far does each teacher travel? They are math teachers here for 8th grade. Mrs. Gribben travels 12 less miles each day than Mrs. Katina. We know something about Mrs. Gribben, not Mrs. Katina. So I'm going to let x equal Mrs. Katina. I'm going to say Mrs. C. Oh, they're both, Mrs. Katina. They're both C's, so I'm going to have to write it out. Mrs. Gribben travels 12 less miles. So if I know Mrs. Katina and I take away 12, I'll know Mrs. Gribben. That's what that says. Oh, she's a G. Yeah, what was I thinking? The difference between the distance Mrs. Katina travels in 6 days. Mrs. Katina, she's the X. In 6 days, so 6x. And difference means subtract. And the distance Mrs. Gribben travels in 5 days, that's a quantity, so I do have to distribute this, is 75 miles. How far does each one travel? So it's distributing a negative, watch your negatives, and solve that and sable. Last question. The length of a rectangle is 5 meters more than the width. If the perimeter of the rectangle is 66 meters, find the length and the width. Well, I always draw my geometry that matches what shape is it that I'm looking at. And its perimeter. That helps remind me that I have 2 lengths and 2 widths. The length of a rectangle is 5 meters more than the width. So I know something about the length. The width I don't know. So I'm going to say let W equal width, just to show you that I don't always have to use X. The width is 5 meters more, so W plus 5, that's the length. And sometimes I go over to my picture and I'll actually write that on the shape. My dimensions that I now know. I know something about them. They're W and W plus 5. If the perimeter is 66, well, perimeter is 2 lengths and 2 widths. So I have a geometry formula that's going to tell me the equation. This perimeter, we know it's 2 lengths and 2 widths of a rectangle. Find the length and the width. So 2 lengths, it's a quantity, W plus 5, so parentheses. 2 widths, not a quantity, so just 2 W's. It has to equal 66. Distribute, put like terms together, solve, watch your label, and sable. And that's it for today. We'll go over this first thing tomorrow in class.